Okay, we're just going to go through the practice exam that we did on Friday. Looking at the first question here, Megan invests $100,000 over 4 years into a simple interest account earning 4%. So that's I equals PRT, which is how we've done it in class, or you can use I equals PIN, which is the same thing, just different letters. And we have $100,000, that's the principal. We've got 4%, which we write as 4 over 100, that's the rate. And then we have 4 years, which is the time. And we plug that into our calculator and we get 100,000 times 4 over 100 times 4 years gives us $16,000. Okay, calculate the total. So the total, T for total, is the original amount she had, the principal, plus the interest that Megan has earned. So that is an original principal of 100,000 plus the interest she earned, which is $16,000, gives her a total of 116,000. All right, Taj invests 7,000 over 2 years, earning 1.5% in simple interest. So simple interest means that we start with the I equals PRT formula. The principal is $7,000. The rate is 1.5%, which we write as 1.5 over 100. And then the time is 2 years. We plug that into our calculator and we get 7,000 times 1.5 times 2. Times 1.5 over 100 times 2 gives us $210 in interest. Calculate the total that Taj will receive. So the total is the original amount Taj had, the principal, plus the amount that Taj has earned, the interest. So the principal was $7,000 and the interest was $210, giving Taj a total of $7,210. All right, question 3. Ivy borrowed $300,000 over 10 years. If the simple interest loan costed her $45,000 in interest, determine the interest rate that was given. So this is a simple interest question. So again, we start with I equals PRT. Always start with the simple interest formula if it's a simple interest question. And it has given, it says that she's borrowed $300,000. So we know the principal is $300,000. It is asking us to find the rate, so it hasn't given us the rate. So we can just leave an R for now. We'll find that one in a second. It has told us that the time here is 10 years, so we can substitute 10 for the time. And it's told us that the amount of interest she made, so that's $45,000 in interest, we can substitute that for the I, which is interest. So it's $45,000 in interest. Okay. The only thing left to do now is to divide both sides by 300,000 and 10, and that'll leave us with just the R, which is the rate. So we've got dividing the left-hand side by 300,000 times 10 leaves us with just the rate on the other side. We plug that into the calculator and we get 45,000 over 300,000 times 10 years gives us a rate of 0.015, or if we need to give it as a percentage, that is equivalent to 1.5%. All right, moving on to the next question. Rosa borrowed $30,000 at an interest rate of 6%. It says that it's simple interest, so we start by writing I equals P RT, and we start by substituting in the values. We've got $30,000 was borrowed, that's our principal. We've got an interest rate of 6%, that's 6 over 100. We've got the interest owed, so this is asking us to find time, because it says how long did she have the loan for, so we leave the time there, and the interest that was owed was $1,600. This time we divide both sides by the 30,000 and the 6 over 100, leaving us with T on this side and 1,600 over 30,000 times 6 over 100, which gives us a T of, plug this into the calculator, we get 1,600 over 300,000 times 6%, gives us 0.089 of a year. So it didn't hold the loan for very long at all. Did I put an extra zero in there? Yes, I did. I did 300,000, not 30,000. There we go. That looks better. So it is 0.89 years. So less than a year. Determine the amount Micah earns when investing $35,000 over 3 years at 3.5%, which compounds annually. So this one tells us it's compounding, so we use the compound interest formula this time, which is A equals P outside 1 plus I to the N, or we've been using R in class, but it's the same thing. A equals P outside 1 plus R to the N. Determine the amount Micah earns when investing $35,000. So $35,000 is the principal. Over 3 years. So 3 years is the N, that's the time period. 3.5% is the interest rate. And then we plug this into the calculator and we get 35,000 times 1 plus the interest rate, which is 3.5 over 100, all to the power of 3 years, giving us a total of 38805 and 13 cents, rounded to the nearest cent. All right. Determine the amount Jalen earns when investing $5,000 over 2 years at 1.7, compounding annually. So again, it's the compound interest formula because it's a compound interest question. So that is A equals P outside 1 plus R to the N. The principal is $5,000. The rate is 1.7 over 100. And it is 2 years. All right. Entering that into the calculator, we get 5,000 times 1 plus 1.7%. And 2 years, which gives us $5,171.45 to the nearest cent. All right, now this one is another compounding question, but these previous questions were compounding annually. This question here is compounding monthly, so this one's going to be slightly different. So we start off with the same formula, A equals P, 1 plus R to the N. The principal here is 15,000. The rate is still 4.2%. So that's 4.2 over 100. And it is 2 years, so that is to the power of 2. But like I said, this is a monthly question, so there is one small thing we need to watch out for, and that is how many months are there in a year? There are 12 months in a year. Let's put that there. Because there are 12 months in a year, we must remember to multiply the number of compounding periods by 12, and we also need to multiply the denominator of the rate by 12 as well. And that will give us, when we plug this into the calculator, $15,000 times 1 plus 4.2 over 100 times 12 months to the power of 2 years times 12 months, giving us a total of $16,312.04 to the nearest cent. Okay, determine the amount Jack earns when investing $10,000 over 1 year at 0.9% compounding weekly. Okay, so once again, it's a compounding question, so we use the compound interest formula. The principal, we can plug that straight in, that is $10,000. The rate is 0.9 over 100. The number of years is 1 year. But we need to watch out here. It says that it is compounding weekly. Okay, so there are 52 weeks in 1 year. So that means we need to multiply the number of compounding periods by 52. And we also need to multiply the denominator of the rate by 52. And then that gives us $10,000 times 1 plus 0.9 over 100 times 52 weeks in the year, all to the power of 1 year times 52 weeks in the year, giving us a total of $10,090.40 to the nearest cent. Okay, moving on. Sequences. Use recursion to generate the first 5 terms of the following arithmetic sequence. So we've been given the first term, that is T1. So 1 is the first term, and it asks us to make 5 of them. So we grab our calculator. 1 is the first term. I press equals. I press answer. And the amount that I need to add on is 6. I need to add on 6 plus 6. So that gives me 7 as my next term. I hit equals again. That gives me 13 for my next term. I hit equals again. 19 and 25. And I can stop there because it's only asked me for 5 terms. All right. Moving on to question B. Question B starts with a 5. It says there that the first term, T1, is 5. And it tells me that the amount I need to add on is -3. So I press 5, I press equals, and I press answer. And then this time I'm going to add on -3. So that gives me, second term is 2, I press equals again. Third term is -1, I press equals again. Fourth term is -4, I press equals one more time. And my last term is -7. And then I can stop. All right, question C. The first term is 10. I store 10 in my calculator by pressing 10 and then equals. I press answer, and the amount that I need to add on each time here is 1.5. So I go answer plus 1.5. That gives me 11.5 for my second term. Gives me 13 for my third term, 14.5 for my next term, and 16 for my last term. All right, question D. D starts with 100 as my first term, and it tells me to add on -14 each time. We could also say that the difference is -14. So that is 100, press equals, press answer, take away 14, gives me 86, then 72, hit equals again, 58, then 44, and I'm done. All right, question 10. Use the rule for the nth term of an arithmetic sequence to determine the value of the 10th term of the following arithmetic sequence. Okay, so we look up here and it gives us a formula, and you'll have the formula sheet on the day as well. The formula to find the nth term of an arithmetic sequence is Tn equals T1 plus n minus 1 times D. So that is Tn equals T1 plus n minus 1 times D. So the n, it tells us, is that's the number of that's the sort of the position of the term, the 10th term, Tn. So n gets substituted with the number 10. T1 is the first term, so the very first term in the sequence is 4. N, we already said, was 10 because it's the 10th term. So that is 10 minus 1 times D. Now, it doesn't tell us what the difference is here. It hasn't told us, but we can figure it out. We can say from 4 to 8, that's gone up by 4. From 4 to 12, that's gone up by 4. From 12 to 16, that's gone up by 4. So the difference is 4. And so we can substitute 4. Plug this into the calculator. And we get 4 plus 10 minus 1 times the difference of 4 tells us that the 10th term in that sequence is 40. Now, if you get a question like this in the exam, before you move on, double check it using recursion. So that means I press 4 equals, grab my answer, and I'm going to add on 4 each time. So I pressed equals once, twice, 3 times, 4, 5, 6, 7, 8, 9, 10. 10, and the 10th is 40, so I know I've got the right answer. I did it with the formula, and then I double-checked using calculator recursion. All right, this next one starts off with the same formula. Always write the formula first. The term that we're looking for, it is still the 10th term. That hasn't changed. All these questions are the 10th term. The first term here is 10, is the first term in the sequence. The n still here is 10, because it's the 10th term that we're looking for. And the difference this time around is, well, we can see that it's gone up by 10. 10's gone up by 20, 20's gone up to 30, 30's gone up to 40. So it's gone up by 10 each time. We plug that into the calculator. 10 plus 9 times 10 is... Plug it straight in exactly as you read it, and you get, 100. There you go. All right. Next one. Tn equals T1 plus n minus 1 times d. So we can see here the first term is 45. The n is again the value of the term, so that's the 10th term is n. And the difference, well, it's going down by 5 this time. Each time it is losing 5, it is going down by 5, so we're going to multiply by -5. We plug all that into the calculator, and we've got 45 plus 10 minus 1 times -5 gives us 0. And again, we should check these with calculator recursion. So we started off at 45, and then we subtracted 5, gives us second term, third term, fourth, fifth, sixth, 7, 8, 9, and the 10th term is 0. So always do a calculator recursion check just to make sure that you did it right. All right, question D. Same process as before. Start with the formula. Tn, well, n is still 10. That hasn't changed for any of these questions. Doesn't mean it will be 10 in the test though, so always read the question carefully. T1 is a 1. And the difference, what is it going up by? It's gone up by 1.1. It's gone up another 1.1. So it's gone up each time the difference has been 1.1. Giving us plug it into the calculator. The 10th term should be 10.9. And again, we'll double check that with calculator recursion. So we put in a 1 for the first term, hit equals, hit answer, plus 1.1. It's our second answer. The third term, the fourth, 5, 6, 7, 8, 9, and the 10th term is 10.9. Good. All right. Over the page. Use recursion to generate the first 5 terms of the following geometric sequences. The first one is 1, because that's T1. That is, 1 equals answer. But this time we're going to multiply by 4, or that is to say we have a ratio of 4. So I put in times 4 into my calculator, gives me my second term, Press equals again, gives me my third term, sorry. And again, that is my fourth term, one more time, and that gives me my fifth term. All right, the next question. First term is clearly 5. It says that T1 is 5. And my ratio here is it's multiplying by 3. So my ratio is 3. I press 5 and equals answer times 3 gives me my second term. Equals again, gives me my third term. And then one more time to finish the sequence. All right, next one. First term is 100,000. It tells us in the question. The ratio here, well, this time I'm multiplying by 0.5. So my ratio is 0.5. Press equals, press answer, times 0.5. And that gives me my next term is 50,000. Hit equals 25,000. Hit equals 12,500. And then hit equals one more time, 6,250. Okay, question D. Starting off with term 1 is 100, and my ratio this time is 0.75. So I plug in 100 times 0.7, whoops, I didn't press answer, let's try that again, equals answer times 0.75, that looks better. Gives me 75, hit equals again, gives me 56 and a quarter, hit equals again, and then equals one last time. Okay, moving on to E. Question E is 0.1 is my first term. Tells me right there in the question. The ratio is multiplying by 2.5. Tells me in the question. And then I store 0.1 into my calculator by hitting equals, hitting answer, multiplying by my ratio, which is 2.5. And that gives me my second term, then my third term, then my fourth term, sorry, and my last term. All right, moving on to question 12. Use the rule for the nth term of a geometric sequence to determine the value of the 10th term of the following geometric sequence. So we've given a rule at the start, and again this will be on your formula sheet, you don't need to memorize this. Tn equals T1 times R to the power of n minus 1. So write it down, Tn equals T1 times R to the n minus 1. All right. The term that we're looking for is the 10th term. That means that n equals 10, so that becomes T10. T1 is the first term, that is 4. R is the amount that we are going up by, so we can see that 4 has been doubled to 8. 8 has been doubled to 16. 16 has been doubled to 32. So that's going up by a ratio of 2, multiplying by 2 each time, to the power of n minus 1. Well, we said that n was the 10th term, and then we plug that into a calculator. get 4 times 2 to the power of 10 take 1 gives us 2048. All right, next one. Start with the same formula. Geometric sequence. The Tn, well, n is 10 again because we're still looking for the 10th term in the sequence. T10, the first term is 10. The ratio, well, seems to have tripled. It's gone up by 3 times, then 3 has been tripled to 90, and then 90 has been tripled to 270. So we have a ratio of 3. It's multiplying by 3 each time. N is still 10, so that is n minus 1. It becomes 10 minus 1. And then we plug this straight into our calculator. Probably should do the brackets just to make sure. 196. All right, question C. Same deal. Start with your formula. The n in this instance is 10 because we're looking for the 10th term. The first term is clearly 1. The ratio, it seems to be halving each time. So that is a ratio of a half, 0.5. And n, once again, is 10 minus 1. So that's 1 times 0.5 to the power of 10 minus 1 gives us 0.0019. Cool. You can always check these with recursion as well. So if we put in the 1, we put in the answer, and we multiply by a half each time. That's our second term. Hit equals again, that's our third. That's our fourth term, fifth term, 6th, 7, 8, 9, and 10. So we can always use recursion to check these answers as well. All right, question D. Again, it is Tn equals T1 times R to the n minus 1. Tn is T10 because we're looking for the 10th term. The first term here is 100. The ratio, the ratio here is a little bit hard to figure out. In fact, let's just do this over the side. If you get a more complicated one like this, the ratio, you can just take the second term and put it over the first term. So that's 95 divided by 100, and you can always put that into a calculator if you like. It's 95 over 100 is 0.95, so our ratio is 0.95. And then to the power of n minus 1, well, the n is still 10. We plug that into our calculator. And we get 100 times a ratio of 0.95, which we figured out in red, to the power of 10 minus 1 gives us 63.0249, and it hasn't specified how many decimal places, so I'll just leave it there. It hasn't asked us to round off, so I've just put ... Okay. This might be a good one to double check with recursion, just so that we can see that this 0.95 actually is correct. So the first term was 100. We hit equals, multiply it by 0.95. And that gives us our second term, which is 95. We hit equals. That gives us our third term, which is 90.25. And that looks the same as what they've given us here. Hit equals again, and that's 85.7375. Gives us the fourth term, then the fifth, sixth, seventh, eighth, ninth, and finally the 10th, which is the same as our answer. So that's good. All right, question E. Again, we're looking at the 10th term. The first term is already given to us as 1. The ratio seems to be multiplying by 3. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. Whoops. And the n is still 10. This is a nice easy one. 1 times 3 to the power of 10 minus 1. And once again, double check with recursion. Hit 1, hit equals, press answer. Multiply by 3 gives us term 2. Third term, fourth term, fifth term, 6th, 7th, 8th, 9, and the 10th term, which matches the answer.